Hello. So now we're going to look at factoring trinomials where the first coefficient, the leading coefficient, or a, the one in front of x squared, is not just 1, and it gets trickier. Okay, so we saw what happens when a was 1, and it is kind of a guess and check kind of game, and it still kind of is. But there's a different way. There's two ways to do it. So it's kind of like in the beginning, if you want to start it with grouping, what you'll find is the more you do it, the better you'll get it. Like the guess and check method, it really is guessing, but it is something you get better at as you go. So I'll kind of show you how I do it, but first let's try it the more methodical way. Okay, so let's factor 3x squared plus 17x plus 10. Okay, we haven't seen anything like this because the first thing, well, it has to be factored into, well, it has to be factored itself. Now 3 is prime, so it can only be 3 or 1. But here's the grouping method to do it. So you take a times c. And just bear with me. Why does it work? It just works. So a times c in this case is 30. So you take 30. And now it's like you do what we were doing before. You say, what are 2 factors of 30 actually to add to 17? Okay? Think about it. And now everything's being added, so this is the simplest kind. So that shouldn't take you too long to think of. 2 factors of 30 that sum to 17 is 15 and 2. Now take that 17x and split it up into 15 and 2. Okay, it's kind of fun. See, it's like an algorithm. So you write 17 as 15x plus 2x, or you can write it as 2x plus 15x. It'll work either way. Okay, better. And now if you look at it, now remember when we left off when we did factoring by grouping, right? Now we can factor that by grouping. So the first 2 terms, the 3x squared and the 15, factor as much as you can out of there. So factor the, a 3x out of those first 2 terms. And now factor as much as you can out of the second 2 terms, so you can only factor a 2 out of there. And then think about what you're going to have left over. When you factor a 3x out of here, you have x plus 5. And when you factor a 2 out of here, you have x plus 5. And that's how you know you did it right. Okay, it worked. And now remember what you do. You can kind of reverse distribute that to say, okay, that's the same as 3x plus 2 times x plus 5. And that's it. That's the factorization. So for sure, check that. Check that by foiling it back out, right? You might be able to do that in your head, but you will get 3x squared plus 17x plus 10. So that method has its drawbacks, which we'll get into. Right. This gets a little more unrealistic when AC has a lot of factors, and we will see one like that. So if it's a number like 120 or something that has like a million different ways to factor it, it could, or it could be kind of a pain to go through, or it might just jump out at you. I don't know. All right, let's do another one I'm going to just explain to you how I do it, and it is just really a guessing game. So here's how I do it. It has to be 2x something and x something. When we factor this, the first factor has to start with a 2x, and the second factor has to start with just an x. Why? Because 2 is a prime number, which means the only way to factor 2 is into 2 and 1. 2 is the only even prime, remember? So that's the only possibility. So here's what I do. I write that down, literally write that down and just leave yourself a blank. And then I kind of just stare at it until I think of it, which if you've done this before, you know that is kind of like your method. You're just going to kind of look at it until you guess how to do it. So the nice thing here as well, and why this one is conducive to this method, is 3 is also prime. So you know 3 has to be factored into 1 and 3. So literally the only thing you have to decide is where the 3 goes and where the 1 goes. So that's the choice you have to make. And you just have to think, how can I make this 7, right? If I put the 1 here, I have a 2 and a 1 and a 3, and that's only 5. But if I put the 3 there, then I have a 2 and a 3, which makes 6. And then I have another 1, so that makes 7. Okay, so the 3 has to go here. In this case, like I said, that's a primo time to use this technique because you don't have very many choices. It's nice when the numbers are prime. You really only had to choose one thing. And if you chose wrong, you could just look at it and be like, oh wait, it's not that way, it's the other way. Okay? And then check it. Check it. So that's it. That's your most basic factoring by guessing. From this point on, I'm going to say do it whichever way pleases you. I generally always use the guess method. If you like the grouping method, it's nice because it always works. You know what I mean? It is an algorithm. It's a process with steps. So 18x squared minus 9x minus 5. Okay, I guess we're doing grouping. 18 times negative 5 is negative 90. And this is what I mean. 90 has a lot of factors. So you need to just sit here and go, okay, so I need 2 factors of negative 90 that sum to negative 9, which remember what that means. When it's negative, I need 2 factors of 90 that are 9 apart. So just now it's kind of like guessing. So you can list off all the factors of 90 if you want. There's nothing wrong with that. Or you can just think about it. 2 factors of 90 that are 9 apart. Well, it's not 9 and 10. It's not 2 and 45. It's 90 is 6 times 15. Oh, there you go. It's 6 and 15. And then furthermore, so that's fine. So now we split up the minus 9 into what? A minus 15 plus 6. I put that in there, huh? Okay. Very smart. Okay, so we split up the minus 9 into minus 15 plus 6. So now you can do factoring by grouping. So like the thinking is over. You know what I mean? You can stop thinking. So factor as much as you can out of the first 2 terms. I think I can factor a 3x out of the first 2 terms. And then this one looks a little different, and I'll show you what I mean. So you factor a 3x out of the first 2 terms, and you're left over with that. But there's no common factor between the last 2 terms, but that's okay. So essentially what I'm going to do, and this looks kind of funny, is I'm going to factor a 1 out of here. Because when you factor a 1 out of things, nothing happens. So I already had the 6x minus 5 that I wanted. So this just makes it look more like a factoring by grouping. And that'll happen sometimes. Sometimes you don't need to factor anything out of the last 2 terms for the grouping to happen. Or sometimes you actually have to factor a negative 1 out of the last 2 terms to flip the sides. Hopefully we'll see that. But I think this makes it more clear what's about to happen. So now the grouping says, okay, it's 3x plus 1 times 6x minus 5. Okay, and I think that was a good one to do grouping with because 18 has a lot of factors. So I guess that if I had any general rule, that would be it. If A has a lot of factors, it's probably easier to do it this way. Maybe. I don't know. So check that. You get 18x squared minus 15x plus 6x minus 5. Boom. Let's do this one. So I'm going to do this one, I think, by the guess method. And this is trickier because there's more than one way to factor this. So 10's not prime. So you have options for how you start. But fortunately, 3 is prime, right? Less options is better. Okay, so you are more than welcome to do it the grouping way if you don't like my way. Go for it. But here's how you do it. And you literally would write this down. So there are only 2 ways to factor 10. 1 in itself or 2 and 5. So whatever our factorization is, it has to look like one of those 2 things, right? It has to. So it either has to be 10x times plus or minus something, and then x plus or minus something, or 5x and 2x. So now you say, okay, 3 is prime. So like I said, it's not very good math teacher stuff, but I kind of just stare at this until I figure it out. So I say, okay, I got a 3 and a 1, and I need to make a 13. If I had let's say a 3 here, that would give me a 30x. And I can't get back down to a 13 from there. If I had a 1 here and a 3 here, that would give me like a 10 and a 3. Actually, a 10 and a 3 would make a 13. But it's tricky because that's still not necessarily the way to do it. So you could try that, but I don't think that's it. Down here, if I had a 3 and a 1, okay, if I had a 3 here, that would give me 15. And if I had a 1 here, that would bring it back up to 13. Because remember, it has to be negative 13. So if you had your 1 and your 3 here, that would have to add to be 13. But your 2x things have to be 13 apart. So if you put a 3 here and a 1 here, that would give you like a minus 3 here would be negative 15. And then a plus 1 here would be a plus 2x. And that would bring you back to where you need to be. Okay, so that was a peek inside my brain when I do these. All right, one of them needs to be negative, and then, like I said, you need to make something that's 13 apart. Oh, and I already talked you through it, but Okay, so that's got to be it. So it's guess and check, but I think you can do most of the guessing in your head, maybe, or you can just use grouping, right? Okay, so that's it. Check it out. Foil it if you don't believe it. All right, this one looks different, right? So for one thing, it's not a quadratic; it's a fourth degree. For two things, it's all negative looking, and for three things, it's in the wrong order. So we're going to take care of all that. So you have to take care of all that before you do the techniques that we're talking about today. So put it in proper order, descending power order, or what we're calling standard form for a polynomial, where the powers go down. And now you've probably noticed every term has a common factor. So factor out as much as you possibly can. Always factor out as much as you can before you start doing this, our new fancy kind of factoring. Okay, so it looks like you can take a 2 out of every term, right? And it looks like you can take an x squared out of every term. And don't forget, we don't want this first term to be negative. So we're going to consider that a factor as well. And we're going to actually factor a negative 2x squared out of every term. All right, so 2x squared isn't really the greatest common factor. Negative 2x squared is, even though I know it's not there, but it's more. It's more stuff. And besides, now we have it to where we can work our magic on it. Okay, so 2x squared plus 3x minus 5. There's nothing new. I would probably do that by guess and check because 2 and 5 are both prime. But, you do you. So don't forget, you can't just get rid of the negative 2x squared. It has to be in your final answer. So put the 2x and the x there. Okay, it's negative 5, so it has to be 1 positive and 1 negative. So you just think, okay, if the 5 was here, that would make a 10, then there's no way you could get back down to the 3. So the 5 has to go here, right? It's like Sudoku, which is a process of elimination. So 5 has to go here, the 1 has to go here. So that would give you a 2 and a 5, so it has to be minus 2 plus 5. Minus 1 plus 5, I'm sorry. Yes, you know what I mean. We're factoring 5. So it has to be 2x plus 5 and x minus 1. Okay, so I don't really want to summarize because the book does that very nicely. So look at the chart on page 392. It just tells you, okay, if you see it like this, maybe try doing it this way. If it kind of looks like this, kind of try doing it this other way. And there's no rule. Either technique we just talked about will absolutely work on every single one of these. So I'm not going to judge. And the funny thing about these, if you do it with a guess and check method, there's like not really a lot of work to show. So that's fine because you are just kind of guessing. Okay, so look at that chart and get in there and do some of these because they're kind of tricky. Okay, thank you.